Okay, so this is the second part of our lesson on solving quadratic equations by using the quadratic formula. Okay, so remember in the first part we solved quadratic equations using the quadratic formula. This is the second part. Remember that the quadratic formula, given a quadratic equation in standard form, ax squared plus bx plus c equals 0, that given a, b, and c, we can substitute those values into the formula, which is the opposite of b, plus or minus the square root of b squared minus 4ac, all divided by 2a. And so we had some discussions about the fact that some students don't extend this line like they should. All right, so make sure it is going from negative b all the way to the end of the radical symbol. Okay, and then all that's being divided by 2a. So in part one, we talked about this sheet right here, about the formula, about the steps to solving a quadratic equation using the quadratic formula. We're going to go through that process again. So in number one, let's suppose, okay, in directions say solve each quadratic equation. Okay, now keep in mind that in a previous lesson and even the first part of part one, we solved some quadratic equations by factoring, but not all quadratic polynomials are factorable. So since not everyone's factorable, remember you had some prime quadratic polynomials, we had to resort to the quadratic formula. So the quadratic formula can be used with any quadratic equation. Okay, so the quadratic formula can be used with any quadratic equation. Okay, so let's look at the first one. So in example one, let's suppose we had 3x squared minus 8x equal negative 9. All right, so 3x squared minus 8x equal negative 9. Okay, so remember it's got to be in standard form. So remember this is standard form right here. So keep that in mind, that's standard form of a quadratic equation. And so I have to bring the negative 9 over. So when I do that, I'm going to get 3x squared minus 8x plus 9 equals 0. Because remember, we are adding 9 to both sides, right? So I get that. Now at that point, you need to determine what a, b, and c are. So a is 3, the coefficient of x squared. B is the coefficient of x, which in this case is negative 8. Make sure you are careful with all that. And c is your constant, which is 9. And so now we're going to substitute all this into the formula. So I get x equal. All right, so remember this reads as the opposite of b. So b is a negative 8. The opposite of negative 8 is a positive 8. Plus or minus the square root of. And remember in part one, when we did this, we put all this in parentheses. So in other words, I'm put b in parentheses. B is negative 8. I am squaring it. So if you didn't put in parentheses, your calculator would give you a negative 64. And we had the discussion that b squared is always positive or 0. It's never negative. Minus 4 times a is 3, times c, which is 9. All of that, see how I went from 8 to the end? All of that's being divided by 2 times 3. So I get 8 plus or minus the square root of negative 8 times itself is 64. Right, and then a negative, think of this as negative. Negative times a positive is a negative. So I'm going to be subtracting. And then 4 times 3 times 9, so 12. 12 times 9 gives me 108. So minus 108, all divided by 2 times 3 is 6. So I get 8 plus or minus the square root of. So again, we're simplifying the the radicand. Remember, this is also called the discriminant. The radicand is also called the discriminant. So this b squared minus 4ac, we hadn't talked about that, but that's called the discriminant. Okay, the discriminant. So 64 minus 108 gives us negative 44. Okay, all divided by 6. All right, so that's where I'm at. Now, in previous lessons, you learned how to simplify a radical. Okay, so let's talk about the square root of a negative 44. I'm going to go off right here and do that. So square root of a negative 44. Now, remember, I'm taking the square root of a negative number, right? So that's not a real number. So those are going to be imaginary solutions. Okay, so imaginary solutions. So remember, you take the square root of a negative number, that's where you're going to get that imaginary unit I. So here I can write this as the square root of a negative 1 times the square root of 44. Okay. Now let's talk about the square root of 44. What perfect square goes into 44? The largest one. So the largest one would be 4. All right, now remember, square root of negative 1 by definition is I. And I can write, so this is I. So I can write this as the square root of 4 times 11, correct? So it becomes I times the square root of 4 is 2 times the square root of 11. Now remember, in a previous lesson we talked about how to write this. So the way I would write this is put the I between the 2 and the square root. So that'll be 2I square root of 11. All right, so that goes here. That's 8 plus or minus 2I square root of 11, all divided by 6. Now remember, at that point, so I'm going to go ahead and rewrite this to have that discussion again. At that point, remember, you still want to simplify. So I simplified the radical. I did do that, but I need to simplify what I see here. Meaning this. So remember in previous lessons I said when you get to this point and you've already simplified the radical, circle this number, the number in front of the radical, and the denominator. And ask yourself, is there a GCF other than 1 for 8, 2, and 6? And the answer is yes, because 2 goes into 8, 2, and 6, right? Okay, so what that means is this. What that means, I'm going to write that here. What that means is I can reduce this. I can simplify by reducing. So basically I'm saying 2 into 8 is 4, 2 into 2 is 1, 2 into 6 is 3. Okay? And so then this right here becomes 4 plus or minus 1 times I squared root of 11 is I squared root of 11, all divided by 3. And that's your answer. Okay, so that will be your solutions. So notice I have 2 imaginary solutions. Now my math lab, you're going to write this as separate solutions. So you're going to say 4 plus I squared root of 11 over 3, comma, 4 minus I squared root of 11 over 3. Okay? All right, so that was number 1. So remember, before you continue with part 2, make sure you look at part 1, because part 1 we did about 7 problems or so with solving quadratic equations. So this is part 2 now. Okay, number 2. Okay, so let's suppose in number 2 I had this. I had x times 12x plus 7 equal 12. Okay? All right, so that looks a little different than the first one we did, all right, which is this, and then the problems from part 1. So remember, when solving a quadratic equation using the quadratic formula, or even factoring, it has to be in standard form. So it has to look like ax squared plus bx plus c equals 0. Okay? In this case, it doesn't look like that. But look at what we have here. All right? So in a previous lesson, when you saw this, what was your first inclination to do when you saw something like this? Well, your first inclination was to use a distributive property, right? Okay, so let's go ahead and do that. So I'm going to go ahead and distribute. So I get 12x squared. X times 12x is 12x squared. X times 7 is 7x equal 12. All right. So now that kind of looks like number 1, doesn't it? Like number 1 right here. So it looks like number 1. So now I'm going to put it in standard form. So I'm going to subtract 12 from both sides. And when I do that, I get 12x squared plus 7x minus 12 equals 0. All right. So now let's determine a, b, and c. So remember, a is the coefficient of x squared, so that's 12. B is a coefficient of x, that's 7. And c is your constant, so that's negative 12. All right, so let's go to the quadratic formula. So the quadratic formula says I'm going to take the opposite of b, plus or minus the square root of b squared minus 4ac. The discriminant is b squared minus 4ac, all divided by 2a. And so I get x equal. All right, the opposite of b. So b is 7. The opposite of 7 is a negative 7. Plus or minus the square root of b, which is 7. Put that in parentheses. Square minus 4. Put all these in parentheses right here. A, b, and c. Minus 4 times a. A is 12. Times c, which is negative 12, right? All divided by 2 times a, and a is 12. Okay? So I get negative 7 plus or minus the square root of 7 times 7 is 49. Now think of this as a negative times a positive times a negative. So a negative times a positive times a negative is a positive. So it'll be 49 plus some number. Okay, now let's talk about 4 times 12 times 12. So 4 times 12 equals 576. Okay, all divided by 2 times 12, which is 24, right? Okay. So now that becomes negative 7 plus or minus the square root of, now go ahead and simplify the radicand again. So that's 49 plus 576, which gives me 625, all divided by 24. All right, so that's where I'm at. Okay, so remember when we got to this point here, right here, we went ahead and we simplified the square root of negative 44. You want to do the same thing here. You want to simplify the square root of 625. You may say, well, that's a large number. Well, what I would do first is check and ask myself, is 625 a perfect square? So in other words, if it is a perfect square, I should be able to take the square root of it and then get a whole number. So let's check. The square root of 625 is 25, a whole number. So yes, that is a perfect square because 25 times 25 is 625. All right, so 625 is a perfect square. So in other words, I get this. I get negative 7 plus or minus 25 divided by 24. So remember from our discussions in previous lessons, my solutions, since 625, since the discriminant, since the radicand is a whole number, I'm going to get rational solutions this time. Rational solutions. So those are going to be real numbers. So I'm going to get, but they're going to be rational solutions. Remember, real numbers are either going to be rational or irrational. And number one, my solutions were imaginary. Those were not real numbers. Because remember, you can't take the square root of a negative number and get a real number. Okay, so when you're at that point, remember what you had to do. You got to remember this. You had to then separate it and actually tell me what those two rational solutions are. So at that point, what I would do is I would say negative 7 plus 25 divided by 24, comma, and then negative 7 minus 25 divided by 24. Okay? And so negative 7 plus 25 is 18 divided by 24, which reduced. They're both divisible by 6. The GCF is 6. So I get 3 over 4, 3/4 over here. Negative 25 and a negative 7 is a negative 32 divided by 24. Those two numbers, the numerator and the numerator and the denominator, the GCF, the greatest common factor of those two is 8. So negative 32 divided by 8 is negative 4. 24 divided by 8 is 3. So those are your solutions. So my solutions are x equal 3/4, comma, negative 4/3. Okay? All right, that was number 2. All right, number 3. So let's suppose in number 3, I had this. I had x plus 4 times x minus 1 equal negative 2. So x plus 4 times x minus 1 equal negative 2. Okay, now I want you to remember what we did in number 2. So number 2, you see where if I cover up the right-hand side and I have this, and your inclination was to get rid of the parentheses, and you do that by using the distributive property. Because I had a monomial times a binomial, and so it is distributed, right? Okay, let's talk about number 3. How are you going to deal with this? So notice I have a binomial times a binomial. So could I multiply the side by using a FOL method? Okay, so remember you have to at some point get it to standard form. All right, so at this point you need to get rid of those parentheses, and to do that I'm going to use the FOIL method since that's a binomial times a binomial. Okay, let's do that. So x times x is x squared. The outer is a negative x, right? The inner is positive 4x, and the last, and positive 4 times a negative 1 is a negative 4 equal negative 2. Combining like terms over here, I get x squared plus 3x minus 4 equal negative 2. Okay? All right, now that's where I'm at. Now, think about what the next step is. So now that it kind of looks like this, can I easily now get it to standard form? And the answer is yes. So I'm going to add 2 to both sides. And then combine like terms, I get x squared plus 3x minus 2 equal 0. Okay? All right, now, remember, you can try factoring. It's not going to factor. So I would just resort to using a quadratic formula. But remember, you got to make sure that A, B, and C are written correctly. So A is a coefficient of x squared, that's 1. B is 3, and C is negative 2. And remember, your formula is the opposite of B, plus or minus the square root of B squared minus 4AC, all divided by 2A. So then I get x equal the opposite of B. Well, B is 3. The opposite of 3 is a negative 3, right? Plus or minus the square root of B, put that in parentheses, 3 squared, minus 4 in parentheses, put all those in parentheses, 1, times C, which is negative 2, all divided by 2 times A, which is 1. Okay? So then I get equals, let's simplify the radicand, negative 3, plus or minus the square root of 3 squared is 9. All right, a negative times a positive times a negative is a positive. Okay? 4 times 1 times 2 is 8, all divided by 2. So I get negative 3 plus or minus the square root of 17, all divided by 2. All right, so that's where I'm at. Okay, so remember what we had to do. So I was given this. All right, and so notice that the left side it doesn't quite look like I want it to look. It doesn't quite look like it did in number 1, right? Didn't quite look like this, or in number, or at some point in number 2, like it did here. So I had to use the fold method to get it to that point. All right, and so I get it in descending order, I get it in standard form, and then I determine A, B, and C, and I substitute and go through all that work. At that point, you got to ask yourself, can I simplify the square root of 17? Besides 1, is there a perfect square that goes into 17? No, 17 is prime, right? So then, remember what that means then, since I'm not taking the square root of a negative number, that's my solutions are real. Remember, if they're real, they're either rational or irrational. Can you tell me if this is rational or irrational solutions? Yeah, good. So it's irrational, right? Because the square root of 17 is not a perfect square. I have a square root here. So those are irrational solutions I'm going to get. Irrational solutions. So, and you can't simplify that, so there's your answer. All right. So make sure you understand before you get to college algebra why is this irrational? Why is the other one rational? Okay. So remember, a rational number, you should be able to write your numbers as an integer divided by integer. Well, square root of 17 is not an integer. Okay. It's a decimal that has no repetition and never ends. All right. So just keep that in mind. So that's irrational. In my math lab, you're going to separate S2 solutions just like this. Okay, so just another way of writing this. All right. Now also keep in mind, when we've talked about this in another part of our lessons, but you could write this as two separate fractions. In other words, you could say negative 3 halves plus square root of 17 over 2, negative 3 halves minus square root of 17 over 2, right? So this divided by 2, this divided by 2. Okay, so these are all just different ways of writing the same solution. And you could have done the same thing here. You see right here? You could have said negative 3 halves plus or minus the square root of 17 over 2. So these are just all different ways of writing your solution. But paper pencil, leave it like that. As long as you simplify the square root of 17, okay, which in this case cannot be simplified. Just make sure you simplify your radical if you can. All right, number 4. Number 4, let's suppose we had this now. All right, number 4. All right, let's suppose we had x minus 6 times x minus 2 equal negative 23. So x minus 6 times x minus 2 equals negative 23. All right, so it's just like the previous one. So I have to use the fold method to get it to that standard form. So I've got to get rid of these parentheses. Since I have a binomial times a binomial, we use the fold method. So x times x is x squared. The outer is a negative 2x. The inner is a negative 6x. And the last, negative 6 times negative 2 is a positive 12 equal negative 23. And then, okay, so I'm going to go and change this to negative 13 right here. Change it to negative 13. All right. Okay, so now at that point, I'm going to add 13 to both sides, right? Well, let's first of all combine like terms over here. So that's x squared minus 2x, minus 8x, combine like terms, plus 12 equal negative 13. All right, now, yeah, go ahead and change to the negative 13 because I just realized that I wanted this to be something different. So just negative 13, negative 13. Now I'm going to add 13 to both sides, just like that. So you got x squared minus 8x plus 25 equal 0. All right, so that's where I'm at. Okay, so let's use the quadratic formula. It's not factorable. You can try. It's not factorable. Don't waste your time. I would go unless you're told solve by factoring. Go directly to quadratic formula. So a is 1 again. B is negative 8, and C is 25. Right? Okay. So remember your formula. The opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. So I get x equal the opposite of b. Well, b is a negative 8. The opposite of negative 8 is a positive 8. Plus or minus the square root of b, which is negative 8. I'm squaring it. Minus 4 times a, which is 1, times c, which is 25, right? All divided by 2 times a, which is 1. So I get equal 8 plus or minus the square root of. So I'm just going to simplify the radicand, simplify that discriminant. So negative 8 times itself is a positive 64. Remember that whenever you square b, b should always be positive or 0. Okay, now a negative times a positive is a negative, so I'll be subtracting. 4 times 25 is 100. Y'all agree? All divided by 2. 64 minus 100, so 8 plus or minus the square root of a negative 36, correct? All divided by 2. All right, so that's where I'm at. Now, before I go on, I'm going to ask you, are my solutions going to be real or imaginary? Are my solutions going to be real or imaginary? Okay, so imaginary, right? Because I'm taking the square root of a negative number. So I'm going to have that I involved. All right, so I'm going to get imaginary solutions. Imaginary solutions. Okay, now, but I got to simplify the square root of negative 36. All right, so let's go over here and do that. So the square root of negative 36, y'all agree, is the square root of a negative 1 times the square root of 36. And I know the square root of a negative 1 by definition is I. The square root of 36, 36 is a perfect square. So what's the square root of 36? 6. So that's going to be 6i. Okay, so that goes here. So I get 8 plus or minus 6i divided by 2. All right, so that's where I'm at. Now, listen carefully. So think about our discussion earlier when we did this one. So remember, we went to that point and it said simplify if you can. Okay, remember all that? Okay. So I'm going to go ahead and I'm going to rewrite this over. So I'm going to rewrite that here. 8 plus or minus 6i divided by 2. All right, so I'm going to circle. So because you would need to see if you can reduce anything. So I'm going to circle. You got to do it like this. So you got to circle this, this, and this. And then ask yourself, what's the GCF of 8, 6, and 2? It's 2, right? So it means that all those three things I have circled are all divisible by 2. So in other words, I can say this. I can say 8 divided by 2 is 4, 6 divided by 2 is 3, 2 divided by 2 is 1. And so basically what I end up with is this. I end up with 4 plus or minus 3i. Now I'm going to put 1 for the moment, okay? But I need for you to remember this. Don't leave it like that because any numerator divided by 1 is that numerator. So the answer is just 4 plus or minus 3i. So I need for you to remember that when you divide by 1, it's just that numerator. You got to remember that. Now in my math lab, you're going to write as two separate solutions. So you're going to say 4 plus 3i, comma, 4 minus 3i. Okay? All right, so that was that. Now, it is possible that you could have done this, that when you got to this point, I just want to show you this. Remember a while ago we said we could break this down into two fractions? So you could have said 8 divided by 2 plus or minus 6i divided by 2, and then reduce at that point. What's 8 divided by 2? 4 plus or minus. What's 6 divided by 2? 3. And you get this still, right? Okay, so you could have done that as well. All right, so that's number 4. Number 5. Okay, Okay, number 5, let's suppose we had this. We had 3x squared plus 5x equals 0. Okay, so you all agree, first of all, that this is already in standard form, right? You may say, yeah, but the c's missing, the constant's missing. That's okay. Let's just deal with that. I want to go ahead and use this. I want to go ahead and do this using quadratic formula. So all these problems we're doing are being done by the quadratic formula. Okay, just that's the way we're doing it. Quadratic formula. In fact, we had to for most of those because most of those were either imaginary solutions or irrational solutions. So we had to revert to the quadratic formula. So this is in standard form. So I'm going to ask you, what is A? A squared plus x squared. That's 3. Good. B. 5. No big deal at this point, right? But then what's C? What's your constant? And so some of you may say, I don't know. Yeah, you do. It's 0, right? Because look, see this right here? 3x squared plus 5x plus your constant. Well, a constant 0, right? And so these two terms added to 0 is still those two terms. So C is 0. All right, now let's go to the quadratic formula. The opposite of B plus or minus the square root of B squared minus 4ac, all divided by 2a. So I get x equal the opposite of b. So b is 5. What's the opposite of 5? Negative 5. Plus or minus the square root of b, which is 5 squared, minus 4 times a is 3, times c, which is 0, all divided by 2 times a, and a is 3. Let's simplify the right hand. So I get negative 5 plus or minus the square root of 5 squared is 25. All right, now look at this carefully. What's a negative 4 times 3 times 0? There's your 0, right? And 25, well, let me go ahead and do this. So that's 6. And then 25 minus 0 is 25, correct? So negative 5 plus or minus the square root of 25 over 6. All right, now simplify this. What's the square root of 25? Square root of 25 is 5. So that's negative 5 plus or minus 5 over 6. So what kind of solutions do I get? So obviously I'm not going to get imaginary because I'm not taking the square root of a negative number. So this is either, so I'm going to get real solutions. Is it rational or irrational? So notice 25 is a perfect square. I don't have a square root anymore, so it's rational. So I get rational solutions. Now remember, a rational number is a number that can be written as a fraction where you have an integer divided by integer. So since these are rational, remember what you do, you have to go further with it. So you're going to say negative 5 plus 5 over 6, negative 5 minus 5 over 6. Okay. And then, what's negative 5 plus 5? 0. But you got to know this. Don't leave it like this. You have to know that 0 divided by 6 is what number? 0. Negative 5 and negative 5 is a negative 10, right? Divided by 6. Reduced is negative 5 thirds. So those are your two solutions. So my solutions are x equal 0, negative 5 thirds. Okay, so 0, negative 5 thirds. All right? Now, I want to come back to number 5 again. So I'm going to put number 5 again. Okay, so here's number 5 again. So in this number 5, we solved using quadratic formula. So you saw what happens when c is 0, right? So when c is 0, this part of your discriminant is always going to be 0. So you're just going to be left with b squared. And so this will always be, when that's 0, this is always going to be a perfect square. So this is always going to be a rational solution. When I come here, though, I just want you to notice, do y'all realize you could have factored this? You could have solved this by factoring. So I could factor out an x, right? I get x times 3x plus 5 equals 0. And now I can use the zero factor property. So I have two factors whose product is 0. So I set both of them equal to 0. And then I solve for x. Well, x is already by itself here. So there's my solution. See right here? And over here, when I solve this linear equation, I get 3x equal negative 5. So x is a negative 5 thirds, which is this one right here. All right, so you could have solved this one by factoring, but remember, we want to do this by using a quadratic formula. Okay, number 6. All right, number 6, we have 4x minus 3 squared equal 5x. 4x minus 3 squared equal 5x. Now, I'm going to say this. Some of you are going to be inclined to do this. you're going to want to take the square root of both sides. Remember, we can only use the square root property. You can only use the square root property if you have an expression squared, which I do, equal a constant. That's not a constant. See, that's not 5. It's what? 5x. So I can don't use the square root property here. The square root property only applies if this side's a constant. All right, so what I'm going to do, just to give you an idea, and then you're going to remember what to do from previous problems in this part. I'm going to write this. Remember, 4x minus 3 squared means 4x minus 3 times itself, doesn't it? I'm going to ask you, do you know what to do now? All right, so some of you probably do, some of you probably don't. So I'm going to go back to this then. I'm going to ask you again. What do we do in number 3? Doesn't it kind of look like number 3 right here? This and this. So what do we do in number 3 at this point? We FOIL, didn't we? So let's go ahead and FOIL this. So we're going to FOIL. So when I FOIL, I get 4x times 4x is 16x squared. The outer is a negative 12x, right? The inner is also a negative 12x. And the last, a negative 3 times a negative 3 is a positive 9 equal 5x. Combine like terms, I get 16x squared. Negative 12x and a negative 12x is a negative 24x plus 9 equal 5x. And now I need to put in standard form, so I'm going to subtract 5x from both sides, just like this. Align my like terms. And so I get 16x squared. A negative 24x and a negative 5x is a negative 29x plus 9 equal 0. Now it's in standard form. Okay? All right, so remember what you have to do. Number 6, when you had something like this, you have to write out twice, FOIL it. All right, you could not use the square root property because that's not a constant. That's a variable expression. Okay, so let's determine A. So A is 16, B is a negative 29, and C is 9, right? Okay, so the opposite of B, plus or minus the square root of B squared, minus 4AC, all divided by 2A. Okay, so I get X equal. The opposite of B, well, B is a negative 29. The opposite of negative 29 is a positive 29. Plus or minus the square root of B, which is a negative 29 squared, minus 4 times A is 16, times C, which is 9, all divided by 2 times 16. Okay, so I get 29 plus or minus the square root of, all right, using the calculator, a negative 29 times itself will give me 841. Okay, all right, now a negative times a positive is a negative, so I'm going to be subtracting. 4 times 16 times 9 equals 576, all divided by 32. All right, so 841 minus 576 becomes, all right, so 841 minus 576 gives us 265, all divided by 32. Okay, all right, so that's where I'm at. Okay, now 265 is not a perfect square. You can check on that and see. So if you check the square root of 265, so you get that, right? Okay, so we know it's not a perfect square. But you got to ask yourself, can I simplify the square root of 265? Okay, you need to if you can. So if you look at the perfect squares, so remember your perfect squares are 1, 4, 9, 16, 5 squared 25, 6 squared 36, and so on, right? Okay. Besides 1, you got to figure out, will any of these perfect squares go into 265? All right, so you see that 5 in the end, though? Now, 5's not a perfect square. But see that 5? I just want to show you something. If I do 265, do y'all agree that 265 will be 5 times, it's divided by 5, so it'll be 5 times 53? And if you look at this real quickly, 5's a prime number, 53 is also prime, isn't it? Okay, so 53 is prime. So those are 2 prime numbers. And notice that I can't go any further with that. So none of these perfect squares except one goes into either of those, right? All right, so I cannot simplify the square root of 265. So 265 can't be simplified. Okay? All right, now, so that's it. You're done. There's the answer. That's the answer to that. All right. Now, in my math lab, you're going to write this as two separate solutions. But on paper and pencil, leave it like that. Okay, so I want you to understand what I did. See, 265 is a big number. And in the previous problems, our big numbers were easy to deal with because they were perfect squares. Here, it's not. So what I got to figure out, what I had to do is figure out if any of these perfect squares besides one would go into 65. And what I did was I noticed that that's a 5. So I remember that 265 is 5 times 53. Those are both primes. I can't do anything else to this because none of these perfect squares other than one will go into any of these. So I can't, this cannot be simplified. Okay? All right, and by the way, is this, first of all, is this a real, are these real solutions or imaginary? Okay, they are real. Imaginary, they're not imaginary because you don't see an I anywhere. You're not taking the square of a negative number. We know they're real. So then it becomes, are they rational or irrational? Well, they're irrational because I still have that square root. So those are irrational solutions. Okay. Number 7. Suppose in number 7 I had this. Number 7. I had 2m minus 5 times m plus 1 equal 3. So again, I'm going to do the fall method again, right? So again, you see that now. So that's the only way I can get this in standard form. So 2m times m is 2m squared. The outer is positive 2m. The inner is a negative 5m. And the last is minus 5 equal 3. Combine like terms, I get 2m squared. 2m and a negative 5m is a negative 3m. Minus 5 equal 3. All right, now remember, I got to get it in standard form, so I need 0 over here. So I'm going to subtract 3 from both sides. So I get 2m squared minus 3m minus 8 equal 0. Okay? So now it's in standard form. So this is in standard form, so we'll go directly to determining A, B, and C. So A is 2. What's B? B is negative 3. Make sure you're careful with all that. And C is your constant, which is negative 8. So I'm going to go directly and putting it back into the quadratic formula. All divided by 2a. All right, so I get m equals, this time my variable is m, so m equals the opposite of b. So b is a negative 3. The opposite of negative 3 is a positive 3. Plus and minus the square root of b, which is negative 3 squared, minus 4 times a is 2, times c, which is negative 8, all divided by 2 times a, which is 2. So then simplifying the radicand, I get 3, plus and minus the square root of 9. Negative 3 times itself is 9. All right, a negative times a positive times a negative is a positive. 4 times 2 is 8. 8 times 8, 64. Okay, all divided by 4. And so then 64 plus 9 gives me 73. So I get 3 plus and minus the square root of 73 over 4. And the square root of 73, it can't be simplified. 73 is a prime number. So you're done. That's your answer. So I get irrational solutions. Okay. All right, number 8. Number 8, suppose we had 5x squared minus 2 equals 0. 5x squared minus 2 equals 0. Again, let's use the quadratic formula. So it's in standard form. You may say, well, I have a missing term. Yeah, you do. That's okay. So it's a in this case. A is a coefficient of x squared, so that's 5. B is a coefficient of x. See, you don't see an x, right? So that's 0. So in other words, I can write this. I just want to see this. I can write this as this, plus 0x minus 2 equals 0. Do you all see that that's the same thing as this? Because 0 times x is 0, right? So you get 5x squared minus 2. So what's the coefficient of x? Coefficient of x is 0. So B is 0. And then C is your constant. All right, now let's go and put that into your formula. Into the formula. Remember, the formula is the opposite of B, plus or minus the square root of B squared minus 4AC, all over 2a. So I get the opposite of b. Let me go ahead and write it right here. B squared minus 4ac all over 2a. All right, so the opposite of b. Well, if it's b of 0, what's the opposite of 0? Well, the opposite of 0 is 0, right? So x equals 0. Plus or minus the square root of b squared, b is 0, go ahead and put it, squared, minus 4 times a is 5, times c, which is negative 2, all divided by 2 times a, which is 5. Okay? Now remember with our discussions, we said b squared will either be positive or what other number can b squared be? 0. Remember, it can never be negative. And in this case, what is it? It's 0, because 0 times 0 is 0. So I get 0, plus or minus the square root of 0. All right, now what's a negative times a positive times a negative? Okay, it's a positive, so I'm going to be adding. 4 times 5 is 20. 20 times 2 is 40. All divided by 10, right? Okay, so I get 0 plus or minus the square root of 40, all divided by 10. Okay, now, here's what I want you to think about. Okay, so first of all, let's simplify the square root of 40. So I'm going to go right here and do the square root of 40. What perfect square goes into 40? Okay, 4. So I can write this as the square root of 4 times 10, right? And then I can write this as the square root of 4 to the square root of 10. And what's the square root of 4? 2. So I get 2 square root of 10. So the square root of 40 is 2 square root of 10. So that goes here. So that's 0 plus or minus 2 square root of 10 divided by 10. What I want you to recognize with that 0 is this. So first of all, I'm going to get irrational solutions, okay? Because 40 is not a perfect square, so you can get irrational solutions. Secondly, what I want you to remember is this. 0 plus 2 square root of 10 and 0 minus square root of 10. So 0 plus or minus 2 square root of 10. Do y'all remember that 0 plus 7 is what? 7, right? 0 minus 4 is what? Negative 4, okay? So just keep that in mind. So remember this. So if I say 0 plus or minus 2 square root of 10, what's the same that? What is that the same as? Well, that's the same as saying plus or minus 2 square root of 10 divided by 10. All right, now, look at this carefully. So I'm going to go ahead and rewrite this over. Plus or minus 2 square root of 10 over 10. Okay. Now, you see this 2 and the 10? Can I reduce that? Yes, because they're both divisible by 2. So this becomes plus or minus. So remember that that's going to be 1, that's going to be 5, right? So that's going to be the square root of 10 plus or minus square root of 10 over 5. So there's your answer. Okay. Now, in my math lab, you would write it as square root of 10 divided by 5, comma, negative square root of 10 divided by 5. Okay? All right, so that is, oh, and by the way, don't make the mistake in reducing 5 and 10 because that's not a 10, that's a square root of 10. All right, the square root of 10 is not 10. So don't say 5 into 5 is 1, 5 into 10 is 2. You cannot do that. Okay? All right, now what, so we did number 8 using quadratic formula. I want to just remind you of something real quick. All right, so let's look at number 8 again. So 5x squared minus 2 equals 0. Okay, so one of the things you learned in a previous course was this. You see, I can, if I want to, add 2 to both sides, right? So I get 5x squared equal 2, no big deal. And then to get x squared by itself, I then divide by 5, right? So I'm going to go ahead and write this over. So divide by 5, and I get x squared equal 2/5. Okay. So since the x term is missing, I just want to show you something, and then remember in a previous lesson, when you had x squared equal 36, what did you do? Well, you took the square root of both sides, right? And then you said plus or minus, and so to get x by itself, since you're squaring, you the opposite of squaring is square root. So you took the square root of both sides. We did plus or minus, and we got x equal plus or minus 6. Okay, so that was from a previous lesson. Same thing here, isn't it? So I want to get x by itself, except this time I'm dealing with a fraction. That's okay. I dealt with fractions in the previous course. So I'm going to again rewrite this over. And so when you take the square root of both sides, so I get the plus or minus, and then the square and the square root undo each other, so I get x equal plus and minus. All right, now here's where you got to remember something from another math course, Math 98. You got to remember that this right here, the square root of 2 fifths, the square root of 2 fifths. You got to remember that I can write this as the square root of the numerator divided by the square root of the denominator. Okay? And then you got to remember, you got to rationalize that denominator. So in other words, you got to say, all right, if I'm going to, see right now, square root of 5 is irrational. You need to rationalize the denominator. So remember what that meant. What that meant was that you had to make the denominator a rational number. It's irrational. And all you have to do to make it a rational number is multiply numerator and the denominator by the square root of 5, by whatever that number is down here. So square root of 5, square root of 5, right? So notice what happens now. The square root of 2 times the square root of 5 is the square root of 10. 2 times 5 is 10. The square root of 5 times the square root of 5 is the square root of 25, right? But what is the square root of 25? 25 is the perfect square. What's the square root of 25? The square root of 25 is 5. And in this right here, okay, so that's this. So that becomes plus and minus. This right here goes here. So it becomes plus and minus the square root of 10 divided by 5. And in that, our solution right here, remember that? Plus and minus square root of 10 over 5. That's what we got here. So you could have used the square root property with this. The problem was that you forgot all about this from last year. That's what you forgot. And so you would have struggled with this probably if you would have gone and used the square root property. But notice it's so much easier just to go ahead and use the quadratic formula. Because nowhere in here did I have to rationalize the denominator. Okay, so just keep in mind some things from last semester that you learned that you could have also used here. But remember, the whole point of this lesson, of part 2, was to solve all these quadratic equations by using the quadratic formula. Okay? All right, so remember, the quadratic formula can use with any kind of quadratic equation. All right? Okay, so that's the end of this part.